Welcome everyone. Thanks for taking time out of your days to visit with us today. Today we're talking about the 9 things to consider when choosing a best fit humidity instrument. This is the 3rd webinar of a 6-part series, and they're all designed to help you make a better measurement of humidity. Everyone who registered for the webinar will get a copy of the recording or a link to the recording and also a link to the slide deck, and we'll send those out within 24 hours. They usually go out tomorrow, the morning after the webinar, the broadcast. Everyone out there is in listen-only mode. That means you cannot talk to us, speak to us directly, but you can interact and ask questions with your chat window. So as we go through the material, as a question comes to mind, go ahead and just type it in the chat session there, and we will have 2 Q&A sessions where we take those questions as they queue up. So feel free, again, you don't have to wait till the Q&A session. Just go ahead and type them in when you think about them. So again, welcome everyone. Glad you could come out today. We know everybody's busy. This webinar is presented and produced by Rotronic Instrument Corporation. And if you don't know Rotronic already, Rotronic manufactures measurement instruments for humidity and a number of other parameters like dew point, CO2, temperature, and so on. So we don't talk about Rotronic products here in this webinar because it's brand agnostic and we talk about it's educational. But of course, if you have questions about Rotronic instruments, give us a call or shoot us an email. Naturally, we'd love to hear from you about that. Speaking today, my name is Bruce McDuffie. I'm with Knowledge Marketing for Industry, the producer of the webinar for Rotronic, and also I happen to have about 10 years of experience with humidity measurement instruments and humidity applications, and I've also taught probably about 100 of these different webinars and seminars all about humidity measurement. Michael Botzkis is your co-presenter today. And Michael's an independent metrologist. He specializes in relative humidity and temperature measurement. And Michael's been involved in manufacturing and calibration of both humidity and temperature for about the past 17 years. Welcome, Michael.
Thank you, Bruce. It's good to be here today.
Great to have you here. And our third presenter today is David Love, and David is the Managing Director for Rotronic in the Americas, and he's been working in the humidity business for about the past 15 years. He's got extensive knowledge about field applications in a wide variety of industries, and David will be working in the chat window, interacting with folks in the chat window, and David will also be moderating the Q&A sessions for us. Welcome, David.
Thank you, Bruce. Looking forward to it.
Glad to have you. Today we'll be talking again about the 9 things that you should be looking at, or the 9 categories you should be looking at to choose a best fit hygrometer. And even if you have hygrometers already in place, we recommend going through this list, because who knows how or why the past instruments have been chosen. Certainly, if you have new applications, this list will help you narrow down for the best fit hygrometer for your applications. We'll talk about the measurement objective, in other words, why you're even bothering to measure relative humidity. We'll talk about the environment you're measuring, what to look at there. We'll talk about the performance or the specifications and how to think about choosing an instrument around that. We'll talk about the parameter. Which parameter will you be needing to know about? We'll talk about measurement reporting, which means how we're going to get that parameter, that output, to where you need it to be used. And we'll talk about the utilization of the instrument and some things to think about there, as well as logistical restrictions. For example, how far away is the probe from the transmitter? And we'll talk about pricing and what to think about when you're pricing different instruments. And then we'll talk about manufacturer and how to kind of judge a manufacturer when you're getting a new instrument. The takeaway today is exactly to understand what you should be looking at and what categories you should be looking at when choosing a hygrometer that's the best fit. Because there's a lot of attributes, a lot of different features a lot of different manufacturers, a lot of different sensors, a lot of different things to think about. And choosing the best combination of those features will help you avoid problems in the future. One of the most common problems we see is people who choose the wrong instrument to begin with. And by choosing the right instrument, again, it'll solve a lot of problems before you even get to them. This webinar also goes hand in hand with our webinar number 2, which was how to choose the best technology, or it was rather pros and cons of different humidity sensor technologies. These go together. It's not a prerequisite that you attended the previous one, but they do work together. So if you didn't see that one, I recommend going and checking out the recording and the slides on the Rotronic website, and I'll have the URL on that towards the end. So again, thanks everyone. Glad to have you. We've got a couple of questions for the audience before we get into the material. And first, kind of judge the expertise of the group out there. What is your level of expertise in humidity measurement? And we'll show the results as they come in. We'll give it a few seconds. Excuse me. If you can share where you think you are right now. Good, we got a few experts out there. Great. We try to balance the material so it's not really basic and it's not too expert. So we always have to have that balance going in these webinars. Go ahead and vote. I'll give it a couple more seconds. Looks like average is by far winning. A few new folks too. Good. Good. I think everybody will find this helpful. Last chance to vote. Okay, go ahead and close the poll. And there's the results. Good. Nice mix today. That's good. Next question about industry. Let's see what kind of a cross-section of industries we have out there today. And again, I'll share the results as they come in. You have to choose the one that's closest to your industry. Like HVAC are still coming in. A lot of engineering firms. Good. I think this is especially helpful for engineering firms where you guys are speccing humidity instruments. There's some others out there too. Give it a couple more seconds. Good cross-section. Nobody in transportation today. I guess they're out driving their trucks. Okay, I'll try to keep those kind of jokes to a minimum for everybody. Okay, there's the results. Engineering firms and a lot of others. Okay. All right, one more to go. Where are you located? Let's get a sense of the geography. I think it's interesting for us to see where folks are coming in from today, and I think it's kind of interesting for you folks out there to know who else is out there, because it may look like you're the only one, but you're not. We got about 100 people on today. Eastern U.S., well represented. Good. We have some folks in South America, Mexico, Canada. Michael's from Canada, so that makes him feel good. Give it a couple more seconds. Okay, I'll go ahead and close it out, and then we'll get into it. There's the results. Thanks, everyone, for voting on those, and I hope you find it interesting. With that, let's go get right into it. We'll switch over to Michael for number 1. Michael, it's all yours.
Okay, thank you, Bruce. Okay, when selecting a measurement instrument, one of the very first things that we need to think about is, what is your measurement objective? Why are we doing this measurement? Why do we want to take it? And what do we want to get out of it? So some things that we may want to be looking at is, are we in a regulated market? Are there some type of regulations that are dictating that we need to make this measurement? These could be federal regulations, local, or maybe it's a quality standard like ISO 9000, ISO 17025, something like that. After that, we might be looking at, okay, we're trying to make a measurement to help us maintain product quality. One great example of this is, as we see in our picture here, we've got our gummy bears. For for these, it's actually very important for the manufacturers to measure the relative humidity. The Haribo company uses the Rotronic sensors to monitor their manufacturing lines, and this helps them create a good quality gummy bear that you get the nice softness to, and it's not too hard. But that's directly related to relative humidity measurements. There could be something in customer specifications that we need to cover. They might specify that something needs to be stored in a certain humidity range, or they might have some other reason for giving a limitation for what the environment can be. We could be looking at human or animal comfort, trying to make sure that a work area is the most comfortable for people so that they get the highest productivity. We're also seeing in a lot of HVAC systems, energy efficiency can be improved by using entropy measurements, making a decision when to bring in outside air or to recirculate inside air. There could be process stability considerations. If your relative humidity is changing too rapidly, that could impact the products. So you need to make sure that you might need to make sure that you've got a stable relative humidity. Another consideration may be to prevent condensation. One application that I saw several years ago was for the Navy. They needed to coat some tanks inside some of their ships. For them, it was very important to make sure that there was no chance of condensation forming on those walls when they're doing the painting, because the point of the painting is to prevent rust. So if there's condensation on the wall and they paint over that, A, the paint won't stick very well, and B, they'll get rust anyways, because that will start from behind the paint. So you may have a number of other things that are coming in and affecting why you're taking the measurement, but it's important to look at what those reasons are, because those are going to help you understand and make some of the decisions for some of the future questions that we're going to go into now. Bruce, I'll pass it back to you.
Okay, thanks, Michael. Number 2 is to understand the environment which you're going to be measuring in. And this is more important for the extreme conditions, but it's a best practice to really answer these different parameters. For example, what's the expected relative humidity range? Will it be just between 20 and 40%, or will it be an entire range from 0 to 100%? What would be the dew point level? If your parameter that you're interested in is dew point, then you should know what kind of a range to expect there as well. PW is the partial pressure of water vapor, and that means you may have to know what is the range of the actual mass of the water vapor in the environment you'll measure. Perhaps the most important thing to understand about your environment is the temperature. Temperature can be is very important when it comes to measuring relative humidity, and some instruments cannot measure in extreme temperatures. So if your temperature is just a place where people work, it's probably going to be a safe bet that most instruments can handle that. But if you're in a more extreme condition where it's very cold or very hot, then that will very much affect the performance of the instrument you choose. Also, pressure ranges. You should understand the pressure variations. And I'm not talking about barometric pressure. That's really, most instruments cover the full range. But I'm talking about pressurized vessels or compressed air systems. You have to worry about the actual sensor performance, and you have to be concerned with the placement of the probe into the pressure. And that goes to what type of fitting you'll need, or will the fitting even match? So you want to know what kind of pressure situation and how much the pressure will be. If you're in a 500 psi gauge, really high pressure tank, not many instruments can handle that kind of pressure. But if you're in a 100 psi gauge compressed air system, there are more instruments that can handle that, but still some don't. So know your environment. The other thing about the environmental conditions is, will the environment be changing quickly? And if it is changing quickly, will you need to know about that change, and how quickly will you need to know as it changes? That can go to the performance of the instrument and how quick the response is. So those are some questions about understanding the environment. It's very important to make sure you know the extremes of the environment and if it matches up with the specifications of the instrument, the sensor, and of course the fittings. And with that, back to you, Michael, for number 3.
Okay, thank you, Bruce. So one of the next questions to ask yourself is, what is the required performance of the instrument? One of the obvious questions there, and this is often going to be your first question here, is what accuracy or what uncertainty am I requiring for my application? This really goes back to question number 1 of what am I trying to do and why am I doing it? So that's probably going to help us make a decision on what's an acceptable uncertainty or accuracy. One application where that comes to mind for this is looking at stability chambers. Here our requirements, the ICH would have defined for us that we need to have our stability chamber within plus or minus 2% RH and plus or minus 0.5 degrees C. So that helps us make a determination of what our requirement is. We now then need to look carefully at what various instruments have for their accuracy or uncertainty specifications. And this is actually a more complex task than what it may seem. I won't get too much into detail on this now. We're actually having one of our future webinars, webinar number 5 on December 10th, going into how to interpret different data sheets and make proper comparisons between different units. Another thing that we might need to look at is the response time in our instrument. As Bruce mentioned, depending on how stable our environment is going to be, our instrument we may need something that has a very fast response time. Another factor in response time would be the filter that's over any sensors. Different filters will also impact the response time of the reading. So we need to be careful about what filters we choose. And we have to understand that some filters are going to make that response time grow longer. And does that cause problem for us? Another performance indicator here is the long-term stability of the instrument. All instruments are going to drift somewhat, and it can vary significantly between different vendors, especially if you have any chemicals in your environment or things like dust or any if you've got humidity controls. Some of those will actually put contaminants up in the air. So you need to be very careful to look at what the manufacturers say the long-term stability of the sensors will be, especially if you know that there's going to be various chemicals in the air. You need to try to find out if those will affect your instrument. The repeatability, hysteresis, and linearity of the instrument are also important considerations. Often they will be built into the accuracy specifications, but not always. Sometimes those are going to be separate on the data sheets, but they do affect your decision on whether or not that instrument will work for you. Output resolution is also important. You don't want to use an instrument that can only tell you a change of 1% RH if you actually need to be able to tell a difference of 0.5% RH. And this will vary from instrument to instrument, so it is something that's important for you to look at and truly understand, okay, what am I trying to do, and how does that dictate or how does that influence what I need to have for the performance of my instrument. Back to you, Bruce.
Okay, thanks, Michael. So by the way, everybody, we've got a Q&A session coming up here in a couple of minutes, so go ahead and type any questions you have so far, and we'll kind of have an intermission break here if there are any questions out there. So far we don't have any, so who's going to be the first to pose a question? How about that challenge? Number 4, what parameter do you need to know about? And this is important because some instruments output more parameters than others. So naturally, you're going to determine what parameter you need to talk about or need to know about or need to input to your controller. And also you need to know how many, get my pointer out here, how many parameters will you need to be receiving. Some instruments output 1, 2, or 3 parameters. Some only output 1. So it goes to choosing, in some cases, how many instruments you'll need. You may need 3 instruments that have 1 output or 1 instrument that has 3 outputs. And that you may have reasons for choosing either one, but it's something to proactively consider. Common industry practice can also drive which parameter you need to know about. For example, natural gas. If you're in that business, the common parameter that the industry talks about is pounds per million standard cubic feet. So if your instrument is outputting dew point and the industry wants to talk about pounds per million standard cubic feet, it makes it difficult to communicate unless you have to do your own calculations. Environmental conditions. This will also drive which parameter you need to know about. For example, if you have a very dry application, then the best parameter that you want to be observing is dew point. If you have other environmental conditions where you need to know the mass of the water vapor, then your output might be parts per million, or it could be mixing ratio. Then when you're thinking about the parameter, you should also think about how will that parameter, that output, be used. Is the output going to be used to control? So that means your output is going to have to match the input to the control system. Is the output only going to be observation? And if that's the case, then what parameter will need to be, what parameter will need to be observed? Or perhaps you're measuring because you want to know, report results to a research and development team. Then you'll need to know what output they need or what they need from you to conduct their research. And finally, regulations might determine what parameter you need to output. Or one of your customers. If you're producing a product and your customer might give you specifications where they need to know a specific range of storage conditions, for example, that you're maintaining their product for. So the parameter is important. It's not always just relative humidity. Another good thing to know is the difference between the sensor technology and the output. Many times the output is calculated, and I recommend going back to our previous webinar on the sensor technologies to learn a little bit more about that. Okay, we have a couple of questions, David, from the audience.
Yeah, we've got a couple of good questions. One that could take a week, probably could use an entire webinar on its own, is from Ivan. He would like us to describe the difference between accuracy and precision.
Sure, that is a great question, and yeah, we should do a webinar on that. Actually, I think we are. Michael, that's right up your alley. Go ahead and take that one.
Okay, Ivan, thank you for the question. So really quickly, accuracy is defined as how close the reading is to a reference or to a target value. So if you think of your classic dartboard or archery target, how close you are to that center point. Precision, on the other hand, refers to how close together a group of readings can be. You can be very precise and not very accurate. So, for example, if you had a number of arrows going to that archery target and they all hit the exact same spot or very close together, but on the outer ring, that would be very precise, but not particularly accurate. The other option then to get accurate and precise would be you get all your arrows right into the bullseye. So accuracy is looking at what you typically see as your error or the difference between your reading and the actual value. And precision is how close together or how tight of a grouping multiple readings can be. Hopefully that answered your question. David, do we have another one?
Yeah, I think it did, because Ivan did respond saying thank you. So I think you've answered his question. Yep. And then Constantine is asking a very simple question, but it is not clear based upon the parameters Bruce was talking about in the previous slide. He needs absolute humidity.
Yeah, I can take that one. The most of these instruments will measure relative humidity. The sensor will measure relative humidity, and then there'll also be a sensor for temperature. And then the third input is pressure. Typically, the pressure is not a live input, but it's just added into the instrument manually in some cases. And then between those three parameters, some instruments will calculate absolute humidity, and they'll report that calculation via an analog output or via the display. I don't know of any instrument that actually measures absolute humidity from the sensor. Do you know, Michael, is there one out there that does that, or is it all calculated?
Not that I can think of offhand. I believe it's always calculated.
Always calculated. Yeah, I think so too. Okay, thanks, David. Do we have another one? We've still got a few minutes for this session.
Got time? Okay, we got it, and I can already know where this question's going. This is heading over to Michael. Tom wants to know, if parameters not built into the accuracy tolerance, should those be added to the accuracy tolerance stated? I'm going to take a leap of faith and think that Tom may be talking about drift, talking about hysteresis. And Tom, if we're headed in the right direction, you don't need to say anything. Michael can address those questions for you. And if we're not in the right direction, just give me a little quick chat, and we'll try to answer more. Michael?
Okay, Tom, that is a great question, and that's actually something I highly recommend you come out to Webinar 5. That is the whole topic of that one. In general, you do need to check with your vendor, but typically, yes. In many cases, the data sheets will show the accuracy, and they will show items like drift separately, and quite often those two need to be combined together. You don't necessarily need to combine them together linearly, like you wouldn't add the two together. There are statistical methods for combining those, and it's using what's called the GUM, or the Guide to Measurement Uncertainty. In there are methodologies for how to combine those to get a relevant or a proper estimate for what your longer term accuracy are going to be. So short answer is yes, those do need to be combined, and you do need to find out what all those parameters are, because there can be a number that you need to put in together, and that great lead into Webinar 5 on December 10th, where we'll go through that in detail and look at several examples and how to combine all those together.
And
David, is there anything else
briefly for Michael? Yeah, I would just add that it is very important to understand that there is no consistency among manufacturers, and it's important to ask the question of the manufacturer what parameters are and are not included in there. So that Tom is happy. He's good there. Got another one here where.
Yeah, let's take one more. Let's take one more, David, and then we'll move on after this one. Yep.
We'll take one more question, and then if everybody in the audience has other questions, keep firing them off, and those questions that we do not answer, we will respond independently offline via email. One more
we also have another Q&A at the end after the presentation too, so we'll give it a shot there too. Okay, David.
All right. So here, this is one of my favorite questions, and I think I'll let Bruce handle this one. Relative humidity, pressure independent.
That is a good question. And there's actually two kinds of answers on this one. And the first one is that relative humidity, if you're to take a sample of air and maintain it in a closed container and you change the pressure, then yes, that will affect relative humidity. As you increase the pressure, then the relative humidity increases. As you decrease the pressure, then relative humidity goes down and it becomes a relatively drier environment. The other question that goes, or answer that goes along with this is that some people say, well, if I take my humidity instrument and I measure relative humidity in Boston at sea level, and then I take that same instrument and I travel to Denver and I measure relative humidity in Denver, that's two different pressures. Will that affect the measurement? And the answer to that is no. In that case, the instrument is measuring the relative humidity in the environment. And if you think about the formula for relative humidity, the actual partial pressure divided by the saturation vapor pressure, you've got pressure over pressure, so they cancel out. The units cancel. So I think that answers the question. Let's go ahead and, okay. Keep those, as David said, keep those questions coming. We're going to have another Q&A session, and if we get so many that come in and we don't have time, as David said, we will get back to you via email. So with that, turn it back over to Michael for number 5. Thanks, David. Good job.
Okay. Thank you, Bruce. So our question number 5, what type of signal will be required? So what we're looking at here is, okay, we've got a measurement device. It has a certain accuracy, but how are we taking the information from that device and how are we using it? What type of systems do we need to feed that information into, whether it be a control system, whether it be a monitoring system, or whether it be people that need to interact with that information. So one common way of, or one common signal that we might want to get out of our instrument would be an analog signal. So this could be a 4 to 20 milliamp loop, it could be a 0 to 1 volt or a 0 to 10 volt signal. This is a very common type of output from various instruments. Often will go into a control system or into some other type of monitoring system. Another type of signal that's becoming more common now as well is a digital signal. So here we'd be looking at something like an RS-232. Potentially we want this instrument on our network, so we need to have an Ethernet signal or a Modbus signal. That's another common control language that we might see. So digital signals may be very important depending what we're interfacing to. We may also want to have a local display. Some instruments may only have a local display, and for record keeping, we're just sending someone around with a piece of paper and we want them to write that down. Or maybe we're just interested in the relative humidity very instantaneously when we're about to do something, and it's good enough for our process to just have someone take a look at a display and then go about their things. Quite often, we actually do want to have some sort of logging of the recording or of the readings. This is very common now. We'll see this in data loggers. They'll have significant built-in memory. Even transmitters will often have some memory there. And this would then come out of the device using digital signals. So that this relates back to something that's going to have some type of digital communication. Often this information is going to go back to some central system, whether it be a continuous monitoring system or some type of building management system. But we need to look at, okay, what are the requirements from those software, from the hardware associated there? What do they need to see from our instrument? And perhaps we're in a regulated market. Life science customers, for example, might have a need to meet the requirements set out by 21 CFR Part 11. This defines having some traceable storage and some security around the storage and security around any digital signatures around the data. So does our instrument allow us to meet the requirements of this standard? Going beyond this, we also need to look at, okay, maybe we need more than one output from this instrument. Maybe we want to know the relative humidity, which is being measured directly, the temperature, which is being measured directly, but maybe we also want one of our calculated outputs. So maybe we want parts per million, and we want that calculated output to come through one of our digital signals. Well, then we need to also make sure that our instrument is capable of outputting those values. In a digital system, it's probably going to be able to do that quite easily. But for the analog outputs, we would have to make sure that there's 3 analog outputs available in that case. Not all instruments are going to come with that many analog outputs. Some might come standard with 1, but you can add on optional additional ones. Some you might be limited to only having 1 or 2, and you need multiple instruments then in order to have all the outputs that you want. So those are all things to think about when you're looking at the signal. And this is, again, looking at how are we going to take the data and then use it. Bruce, back to you.
Okay, thanks, Michael. Number 6 is how will the instrument be utilized? And like all of these points, they work together and they build on each other. In this section, you want to consider how you will be using the instrument. Now, if you have instruments already in place, it may be a question that's already answered. But as I mentioned earlier, it's great to go through this anyways. Perhaps a different configuration would suit your application better than the old way the old instrument is suiting it. So will it be a fixed transmitter? Will it be mounted on the wall with the probe fixed to the transmitter? Or will the probe be on the end of a cable? Will you need a portable device? Perhaps you could be economical if you're in a budget crunch and use a portable meter for multiple places in place of several fixed instruments. Will you be needing to have data logged? And if you do have a data logger, as Michael mentioned, will it have to be compliant to 21 CFR Part 11, for example? Will you be measuring in situ, for example, in a compressed air line or in some other type of pressure device or some other type of enclosed room, for example? Or will you be needing to draw off your air or gas from a certain application via sampling system? And these are all different ways where the instrument could be utilized, and understanding if the instrument you choose will have that capability is very critical. Because again, you don't want to purchase the wrong instrument at first because it just causes problems. Will you need to be able to access this instrument as on a regular basis? And that will determine, for example, if you'll need the probe on the end of a cable that goes to the transmitter, or it could be also help you determine if you'll need a portable meter instead of a fixed meter. I remember an application I worked with once. It was at New Belgium Brewery up in Fort Collins here in Colorado, and they had a big storage tank of, I think it was hops, and they purchased an instrument and they had to place it on the top of the tank. So it was about 40 feet in the air, and they didn't think through that they would have to calibrate that instrument from time to time. So every time they had to calibrate or do any kind of maintenance or check the instrument at all, they'd have to rent a Genie lift and bring it out to the plant, and you go up and check it that way. They could have avoided that if they had thought about how they would utilize the instrument. Will removal cause process disruption? If your application is some type of production that goes 24 hours a day, 7 days a week, 365 days a year, you probably don't want to disrupt or stop that process just to calibrate or just to repair that instrument. Some instruments have an option where you can do a hot insertion and hot removal, or it may be cases where you have a removable probe that you can quickly replace. But it's just something to think about, because you don't want to disrupt your entire factory just for an instrument change. And again, finally, the gas composition. Will the instrument need to measure in a gas other than air? And that was an important question because it could affect certainly the instrument you choose. I think Michael will talk about that a little more in the next one. Back to you, Michael.
Okay, thank you, Bruce. So question number 7, what are the logistical constraints? So these are not so much related to the actual measurement itself, but things that are going to limit what you can do to make that measurement and the environment around your measurement equipment. One of the first things to really look at there is, do we have power available? The vast majority of these instruments are going to require some type of power, whether that be AC line voltage or it be that they're battery operated. But this is an important consideration. I've seen in many situations, especially in large warehouses or something, where people are looking to monitor those, the cost of running the data lines and the power lines can easily exceed the cost of the measurement instrument itself. So this can really drive you into saying, I want something that runs on AC voltage or is battery operated, or potentially you want something that's got a bit of both. So it runs on the line voltage regularly, but it's got battery backup in the case of a power outage. It's good to look at if there's any requirements for NEMA or IP standards to be met by any transmitter cases. So thinking about if the environment is going to see condensation on a regular basis, or is particularly dusty, or if possibly a clean room would be sprayed down. Do we need to be able to handle that type of environment and ensure that our electronics don't get damaged by something that's happening there? The temperature of where our measurement equipment can be important. Not in all cases will the electronics that are part of our transmitter be at the same spot as our measurement probe. We might have our probe in a vat or in a room or some other chamber, and then our electronics could be out in ambient conditions. So we need to look at making sure that the electronics are within their operating ranges, which is quite often going to be different than the operating ranges of our sensors themselves. So the sensors, in many cases, are okay up to 200 degrees C, but definitely our electronics can't be used up at that temperature. So we need to make sure that we're meeting the temperature requirements of both the electronics and the sensors. We could be in an environment where intrinsically safe instruments are required. We've got a picture here of an oil refinery. Obviously, there's going to be a lot of volatiles in the air, a number of things that could potentially cause an explosion or fires, and it could be very important for us to ensure that there's no way that this instrument can cause a spark. So we need to make sure that, in this case, we've got an intrinsically safe unit. And if we're in one of these environments, we also have to understand that the regulations for this are not harmonized globally. Different regions have different requirements, and just because an instrument has been rated to be intrinsically safe in one region, it might not necessarily have that same rating in a different one. So we've got to be careful of that and look out to see, does this instrument actually meet the needs for our location? Some other examples here, if we're measuring in a pressure or vacuum vessel, are we able to make a tight seal against that probe so that we actually can maintain our pressure or maintain the vacuum that we've got? Sample conditioning, for example, if we're using a chilled mirror and we're pulling a sample gas out of a heated chamber, we need to know, or we need to be careful that if that hot gas has a lot of moisture in it, we don't want it running through a long line at ambient temperature, because we're going to get condensation in that line, which will then affect our readings. So potentially we need to have a heated line there, or we need to choose a different tool for making that measurement. We also have to look at the signal, the probe lines, power lines. Potentially our transmitter is going to be a long distance away from where we need to get an analog signal to. In this case, we probably don't want something that has a 0 to 1 volt output on it, because the resistance of the line will affect our readings. We want to be looking for something that's most likely going to have either a 4 to 20 milliamp analog output, or potentially looking for something with a digital output. Going to be lots of different logistical constraints. They're going to vary for every application. So it's important for you to look at what are the things that limit how I'm going to make this measurement for this application that I'm working on now. Bruce, back to you.
Okay, thanks, Michael. Got a question for the audience now, and let's get an idea of the cross-section of different types of environments you're working with. In this slide, you can choose more than one, and I'll share the results as they come in. Is your environment just a benign type of environment where human living conditions, or is it an outdoors environment where you have to likely measure a wider range of parameters? Or a stability chamber, environmental chamber? Or are you dealing with high velocity air or gas, or high pressure gas? And then the last two are about temperature. Are you in a very hot environment, very cold environment? We'll talk in the next slide a bit more about how these different things could affect the price of the instrument you choose. We'll give this one a few more seconds, and again, you can choose more than one. Looks like a lot of folks out there dealing with stability or environmental chambers. And a lot in benign or human living conditions, and that's fairly common. And again, as you're thinking about this and your brains are becoming stimulated with this exciting topic, go ahead and type in your questions. We've got another Q&A session again at the end of the presentation part here. We'll give it a couple more seconds. Thanks again, everyone, for sharing your information. Anonymously, by the way. And I'll go ahead and close the poll. Last chance. Everybody who's in. Okay, there's the results. A lot of chambers. Good, nice mix. And again, go ahead and fire some questions off for us as they come to mind. And with that, we'll go into number 8. And number 8 is many times an important question, especially these days. What is an appropriate price range? And for this, we're going to hearken back to the 1700s and look at Benjamin Franklin's quote. The bitterness of poor quality remains long after the sweetness of low price is forgotten. And that is very true when it comes to choosing a humidity measurement instrument. Typically, when you're looking at an instrument, if you need better sensor performance, for example, lower uncertainty or accuracy if you prefer, you'll have a higher price. If you need to conform to regulations like a 21 CFR Part 11, you'll probably pay a higher price. If you have harsh or extreme conditions, like from our last poll, if you're in very hot or very dry or very cold, or you're measuring in difficult gases, you'll have a higher price. If you're in a human environment and you're just measuring for HVAC and it's not really critical, you could probably get away with a less expensive instrument. If you just need an instrument for your desk because you're a humidity geek like we are, and you just want to know what the relative humidity is in your office, you can probably pick one up at Radio Shack or online for $20 or $30. That's the way to think about the price range. The more difficult or the more critical your application, the more you probably should pay for the instrument. Another thing to consider for price range is the operating cost. And yes, there is operating cost for humidity instruments, typically in the calibration. So if an instrument requires more frequent calibration than another, that goes to the overall price or the cost of that instrument. Also the cost of the actual calibration. If you're requiring an accredited calibration, then that will add more than just a standard calibration. How about spare parts? Does the vendor recommend or require that you carry spare parts, whether it's cables or probes or sensors? That adds to the price. Training and education of the operator. Some instruments are very sophisticated, like a chilled mirror, for example, and they do require training and education to be operated in a proper manner, and that adds to your price. It may not be a direct addition, or it may be if the vendor is providing the training. When that person leaves or turns over, there's an additional cost to train the new person. And that should be considered when you're thinking about the price range. It's not all about the price of the instrument itself. In many cases, the price of the instrument itself is negligible when you think about the cost of losing product or the cost of losing expensive research tissue, for example. I remember a story that was somebody had it was an eye bank. So they had eyeballs, tissue, eyeballs stored in a freezer. And the instrument failed, and they lost all of these eyeballs. And believe it or not, that's a very, very expensive loss. Another one that I remember dealing with was a museum. And the museum had a storage room where they put some priceless art when it wasn't being displayed. And they had very sophisticated humidity control in the room. And they had a transmitter on the wall. They chose a very inexpensive transmitter to control the humidifier. And so what happened is there was an electrical storm, and because it wasn't a robust instrument, it shorted out the instrument, and it failed to 0%. So the little transmitter on the wall is telling the humidifier, hey, our room with all of our expensive art is at 0%. We need more humidity. Send me humidity. And sure enough, the humidifier fired up and flooded that room with humidity, and they got severe condensation, of course, and it ruined all that priceless art. In that case, the $500 they spent for the transmitter was nothing compared to that loss. And when you're thinking about price range, again, if it's critical application, critical products, or a very harsh environment, certainly be willing to pay more. And the last thing is loss of shutting down a system or a service call. What does it cost for a service call for someone to come out and repair or replace an unreliable or non-performing instrument? Again, that can easily wipe out the cost of even a $2,000 or $3,000 instrument. Those are some things to think about the price range. Don't forget old Ben Franklin, the bitterness of poor quality remains long after the sweetness of low price is forgotten. With that, I'll turn it back over to Michael for last point, number 9. Michael?
Okay. The last point for you to ask yourself is, how should I choose the manufacturer? One of the key things that I've always thought about here is, what level of support might I require for my application? Maybe I want to be able to order something really quickly online, a replacement part, or even an instrument. I want to be able to do that real quickly. So it's great if there's a web store available. But especially with relative humidity, I find there's probably going to be some case that comes up at some point where there's something going on that you can't explain, and you need some assistance in dealing with the issue and trying to figure out what's happening. So you want to be able to find a vendor that's available to support you through these, and that has the expertise needed to ask the right questions and get you to the answer that you need to have. You might want to be looking at whether or not there's a service center available locally for you, or at least domestically. If your instrument needs to be calibrated or if it needs to be repaired, is it going somewhere local where you're talking about a one-day shipping, or does it have to go overseas potentially, which is going to add on to the time that's going to take to get something back? How are you treated during the purchasing process? Is the salesperson knowledgeable about what what it is that you're trying to do? Are they knowledgeable about the instrument? Are they asking you these questions to help you make the best purchase that you can, rather than just trying to pad their numbers for the end of the quarter? Is the vendor offering to come out to your site to take a look at what your application is, to really help you narrow down which instrument's going to work for you and what logistical constraints you might have in your application? Another key thing to look at is the warranty period. Quite often, it's fairly standard on an instrument to have a 1-year warranty. Rotronic, for example, has now introduced a lifetime warranty on its instruments. So we'll stand behind the instruments for the lifetime of them, provided that the instrument is sent in for calibration once a year to the Rotronic Service Center. So this is an example of a manufacturer standing behind the product and giving confidence that it will last for an extended period of time. Is your sales rep asking you these 9 questions? Are they helping you come up with the best instrument? So these are all things to look at when selecting your manufacturer. It's important, I believe, to think of your vendor here as a partner. You're going to probably need their help at some point, so you want to make sure you're choosing someone that's capable and available to give you that help when you need it. Bruce, I'll pass it back to you.
Okay, thanks, Michael. So those are the 9 points, everyone, and here they are in summary. And I strongly recommend taking the time to go through this. By finding your best fit instrument, taking some time going through this list, you'll save yourself hassles down the road, no matter what you end up choosing. So with that, let's jump right into the questions.
Well, we got a couple of good questions, Bruce and Michael. Thank you for your time. I think you guys have done a good job. Vincent's got a question that is really, really practical. He wants to know: is there a general rule for instrument length when measuring RH inside of varying sizes of an exhaust duct? Near transitions, near elbows? That's kind of Vincent's question. Throw it out to the group, Bruce or Michael. I don't know which one of you guys want to answer that, but
yeah, I'll take a stab at it. It's typically the important thing when you're measuring relative humidity in a duct. Say, for example, you have a 18-inch probe that's steel or even aluminum. As long as the temperatures are uniform in the duct and in the room, you don't have to worry about that difference. But if the duct has a colder airstream or a warmer airstream than the air outside the duct, you're going to get some temperature creep across that probe. And in that case, I would say you want to put all the steel or the whole length of the probe into that duct if you can. The temperatures are the same. You don't have to worry about that. And as far as air velocity, it really doesn't matter. I don't think it matters where that probe is inside of the duct, as long as you're aware of the velocity. And if it's a really high velocity air, then you should be aware of the filter and the probe of the sensor itself. And transitions near elbows, I don't think that matters too much other than on top of what I just mentioned. David or Michael, do you have anything to add to that?
Well, the only thing that I would
think
throw
that was pretty
into
good.
that, Bruce, the only thing I'd throw into it, Bruce, would be if you do have a pretty significant temperature differential between the outside air, the air outside of the duct, and the air inside of the duct, everybody wants to use stainless steel probes in a situation like that, and I would suggest that perhaps that's not a good solution because the stainless steel probe has got a very long temperature response. Plastic probe might be a better application if you've got a temperature differential. As we all know, metal conducts heat pretty quickly. Plastic's a little slower.
Excellent point. Okay, we might have room for one more question if we have any,
I
David.
got one more question. Yeah, we got one more question, and it has to do with speed of response. Dan is looking to know RH measurement in an apartment. So we'd be looking at residential and office environment, obviously, and he wants something that doesn't take 20 minutes to get to an RH reading. And I would venture to say that that has to do with airflow, Walmart mount sensors versus maybe a little more quick to respond than a Walmart. What do you guys think?
Yeah, do you have some thoughts on that, Michael?
Take a stab at
yeah,
that.
Go ahead. Sure.
Yeah, I think probably, I mean, beyond the basic response time of the instrument, probably a lot of what you're seeing in that particular application is outside influences. So if you've just brought an instrument outside from a car, either a hot car or a cold car, into the apartment, you need to give that instrument time to acclimatize. So this goes down to the heat capacity of the sensor and the probes that David was just talking about. If there's a lot of metal there and a high thermal mass present, it will take longer for that total system to come to equilibrium with the room. There might be other sources of humidity or temperature that could be affecting the reading, and that can be as simple as a user standing right over the instrument, breathing nearby, and your breath, of course, has a lot of water vapor in it, and that can be affecting your readings. So I think there could be a lot of other things to keep in mind here, just in where is that instrument coming from, beyond just the absolute response time of the sensor itself.
Okay, good point. We better go ahead and wrap up here. We're at 2 minutes past the hour, but thanks for those questions, everyone, and thanks, David. And go ahead. You have something, David?
Yeah, we've got a few unanswered questions, and we will reach back out to you guys via email or to address the questions that were not answered.
Absolutely. Okay, last few slides. Check out our Humidity Academy. All kinds of references there. Next webinar is about how to read a psychrometric chart. It's going to be a lot of fun. I hope everyone can join us for that one too. Tell all your friends. This is going to be a good one. You can register at the rotronic-usa.com website. And again, hope to see everyone there on November 12th. And finally, as mentioned, consider Rotronic for your transmitters, portable meters, and loggers. And the Rotronic sales team is fantastic about helping you go through these 9 points. So please consider Rotronic as your source for transmitters, portable meters, and loggers for any of these parameters. Please consider the post-webinar survey. That'll pop up when you close out the webinar. We'd love to hear your feedback. Let us know how we could do better. Let us know if you think we're great. We'd like to hear that too, but mostly we want to know how we can improve for you out there in our audience. And finally, that's it. Thanks, everyone, so much for coming out today and spending time with us. Thanks, Michael. Thanks, David, for your participation.
Thank you to all of our attendees. We appreciate your interest in this subject, and please reach out to our sales team if you have any questions. They're there to help you.
Okay, thanks, everyone. Have a great day, and we'll see you on the next one.